Dante Certification Program Level 3. In previous modules, we looked at IGMP, Internet Group Management Protocol, and how it relates to Dante. In this module, we will be going over testing and troubleshooting IGMP performance on a Dante network. We understand from previous modules that there's a lot of work going on in a switch that's running IGMP, and if you think about it, it has to now look for specific type of messages. It has to trap them, interpret them, and work out how to change its routing table. Then change the routing table and make sure that everything stays current. This entire process can have an effect on switch performance if the switch CPU is involved. So if multicast management involves a trip through the switch's management CPU, then you can see a performance degradation in terms of forwarding delay and delay variability. Using a CPU to forward multicast traffic is detrimental to the switch's overall performance. Some switches will have options to disable this. For example, Brocade allows you to turn this off. Out-of-the-box devices will use the CPU to forward traffic, but you can still turn this off and put it back into the hardware. And what that will do is give you the same performance that you get for unicast, which is what you need. How this can affect things is really in the area of PTP mostly. You might be able to notice on the PTP histogram of some clock spreading. Instead of it being a nice straight line, you will start to see it wander around. Or in an extreme case, you may start to notice some dropouts in the audio as well. So this is something you want to try and look for and avoid. And this is one of the areas where all switches are not made equal. The more money you spend, generally the better switch you get. Another area where multicast becomes a challenge is when you try and punch a VLAN through a router core. As mentioned before, IT departments really do not like this. They get a bit frustrated with it, even though Cisco has a really good technique for it called VXLAN. Multicast can be a challenge in these environments, and it can often be the case where you cannot get all the multicast you were trying to get through the layer 2 trunk, tunnel, or however it's being implemented. This is an area, again, where you may see some variability in PTP performance, or you might see something like Dante reporting that there are multiple clock masters in the network as well. The symptom here is really to do with multicast traffic not propagating across those lines. There are also link technologies that make their way into networks these days like GPON and MPLS. These are generally asymmetric, not designed for multicast or reverse multicast. There's a number of different applications that can impede the passage of multicast from somewhere in the middle of the network out to the edges and back again. This can also occur due to incorrect ACL configurations. So these are the kind of things you can see in a multicast environment that will cause generally PTP disruption, drops in audio, or Dante devices appearing or disappearing. One way of helping to diagnose these problems is to use a feature built into Dante called Unicast Delay Requests. You will see that in Dante View on the Device Config tab of any device. You can turn this on all the devices, and if clocking suddenly starts working, then you know you've got a multicast distribution problem in that network because it converts PTP over to use unicast. Here's a recipe to diagnose if your switch is up to the task of forwarding multicast traffic. Test the audio, then the PTP using the latency graph and the clock histogram. For audio testing, create some Dante multicast flows, then subscribe them to a receiver. Check the latency view in Dante controller, then turn on IGMP snooping in the switch. See how far the latency view has moved. Increase the number of multicast flows through the switch. Check latency performance again. To conduct PTP testing, create some Dante multicast flows, subscribe them to a receiver, check the clock histogram in Dante controller, then turn on IGMP snooping in the switch. See if clock histogram has spread, increase the number of multicast flows through the switch. Check sync performance again.